4 billion years ago, the Martian surface was apparently quite habitable, featuring rivers, lakes and even a deep ocean. We don't know exactly how life on Earth began. The panspermia hypothesis suggests that life could have started elsewhere in the universe and traveled to Earth via asteroids, comets. Some astrobiologists view ancient Mars as an even better cradle for life than Earth was. If Mars was indeed once home to life, then life on our planet may have come here long ago. It could have seeded our own planet with microbes embedded in Martian rocks that were knocked off the planet by another impactor. There are many unresolved mysteries that scientists can't explain. Let's begin the interesting journey. Why humans are so interested in Mars? Is there life on Mars? In 1895, astronomer Percival Lowell documented what he believed were a series of artificial canals crisscrossing the planet, but the canals that Lowell emphatically insisted he saw could not be observed by other scientists. Lowell had found evidence of water vapor, but this result was also unable to be duplicated. Present day, when humans have sent more spacecraft to study Mars than any other planet beyond Earth. To this day there is no evidence of life on Mars, but the search hasn't stopped. The red planet is still a prime target in the search for life. How was Mars in the past? Did life exist on Mars in the past? Mars wasn't always this inhospitable to life. We think Mars once had a molten core that generated a magnetic field which protected the surface from radiation and supported a thicker atmosphere that kept the planet warm. There is also strong evidence that between 3 and 4 billion years ago, Mars had water on its surface. We can see valleys carved by rivers, pebbles that formed in streams, and piles of sediment that could have come from basins and deltas. Under these conditions, life could have been possible. About 3 billion years ago, things changed when Mars lost its global magnetic field. Solar radiation stripped off most of the planet's atmosphere, the liquid water disappeared. This process had transformed Mars into the cold, dry desert we see today. Many believes Mars is cold and dry, but it may not be dead. If Mars had life 4 billion years ago, Mars still has life. Nothing has happened on Mars that would have wiped out life, said by Michael Finney, co-founder of the Genome Partnership. Mars had early life. This is the most optimistic, but still scientifically viable, view of life on Mars. Space missions like NASA's Curiosity rover have determined that long ago, some portions of Mars were habitable for at least some periods of time. Some researchers are pushing to expand the hunt to extant Martian life. One of them is molecular biologist Gary Ruvkun, who's based at Massachusetts General Hospital and Harvard Medical School. Ruvkun is one of 3 principal investigators on the Search for Extraterrestrial Genomes project, which is developing an instrument to detect past or present DNA or RNA-based life on Mars and other alien worlds. Does life exist on Mars now? Thanks to the many rovers, orbiters, and landers that explored Mars in the past, scientists understand that billions of years ago, Mars was a much different place than it is today. Its atmosphere was denser, its climate warmer, and liquid water flowed on its surface. This led to many of the features that are observable today. We've never found any signs of life other than our own Earth life, but many scientists speculate that ancient Mars could have harbored life, and astrobiologists are continuously on the search for how to uncover it. On July 30, 1976, the LR returned its initial results from Mars. Amazingly, they were positive. As the experiment progressed, a total of 4 positive results, supported by 5 varied controls, streamed down from the twin Viking spacecraft, landed some 4,000 miles apart. The data curves signaled the detection of microbial respiration on the red planet. The curves from Mars were similar to those produced by LR tests of soils on Earth. When the Viking molecular analysis experiment failed to detect organic matter, the essence of life, however, NASA concluded that the LR had found a substance mimicking life, but not life. Natalie Cabral is director of the Carl Sagan Center for Research, argues that microbial life could be widespread on Mars, although we Earthling haven't found it yet. Her argument is that, over the past 4 billion years, microbial Martian life might have migrated underground. Scientists says there is a slim chance that microbial life exists on Mars today, perhaps under the planet's ice caps or in subsurface lakes detected by spacecraft like the European Space Agency's Mars Express. Locations like these could protect life from the harsh conditions on the planet's surface. The kind of life that we think could exist on Mars today is microbial. It wouldn't be spotted by the cameras of an orbiting spacecraft. Instead, there are ways we could detect it, indirectly through chemical signatures linked to life called biosignatures. One such biosignature is methane, which can be created by both biological and geological processes. Curiosity has detected methane near its landing site in Gale crater, but this isn't conclusive. The European Space Agency's Trace Gas Express orbiter has not found signs of the chemical in Mars' atmosphere. The Perseverance rover is NASA's 9th mission to land on Mars and is tasked with characterizing the geology, atmosphere, and climate of Mars and help pave the way for human exploration. On February 18, 2021, soon after it landed in the Jezero crater on Mars and almost immediately transmitted its first image of the Martian. This was followed by photos from the Mars Reconnaissance Orbiter and footage taken by the rover's entry, descent, and landing. Will rover's drilling find evidence of fossilized bacteria in Jezero crater? Time should reveal the mystery. What is Mars like today? Mars was once wet, with an ocean's worth of water on its surface. Today, most of Mars is as dry as a desert, except for ice deposits in its polar regions. Where did the rest of the water go? Scientists have theorized that much of the planet's water was lost to outer space as the atmosphere dissipated. The research uses new computer models and found that if Mars once had a global ocean between 328 and 4,900 feet deep, then a significant amount of that water might now be stored in the planet's crust, sucked into the red planet's rocks. And there it remains, trapped within minerals and salts. Indeed, as much as 99% of the water that once flowed on Mars could still be there, the researchers estimated in a paper published in the journal Science. The data and simulations also indicated that the water was almost all gone by 3 billion years ago, around the time on Earth when life consisted of single-cell microbes in the oceans. This means that Mars has been dry for quite a long time. Mars' thin atmosphere and its greater distance from the Sun made Mars much colder than Earth. Mars is on average inhospitably cold, with average temperatures of -80 degrees Fahrenheit, that is -60 degrees Celsius. Summer highs occasionally reach 86 degrees Fahrenheit, that is 30 degrees Celsius. The atmosphere of Mars is also roughly 100 times thinner than Earth's, but it is still thick enough to support weather, clouds and winds. It's having 95.3% carbon dioxide, 2.7% nitrogen, 1.6% argon, 0.13% oxygen, 0.08% carbon monoxide, also minor amounts of water, nitrogen oxide, neon, hydrogen deuterium oxygen, krypton, and xenon. Without a magnetic field, its surface is bombarded by the sun's radiation. The low atmospheric pressure combined with cold temperatures also mean liquid water is not stable at the surface. Life as we know it cannot exist in these conditions. Then why humans are so interested in Mars? Could humans bring life to Mars?